Good morning, guys. It's Miss Hewitt, and today I wanted to do a fun math talk with you guys. So during a math talk, I'm going to write out the problem, and then you're going to pause the video, and as Miss Chris would say, you're going to mash that pause button, and you're going to pause the video and work the problem out for yourself. If you're unable to work it out for yourself, if you're truly unable and you're like, I'm stuck and I need to watch Miss Hewitt do it, then you can do that, and that's totally fine. But I would also really like it if you can solve it to try doing it on your own, just because this is review, something that you should be able to do on your own. I'm not making it too difficult and I'm not making it too easy. So something you should be able to do on your own. And then after you're finished, you're going to hit the space bar or the unpause button, so play, and then you're going to watch me work out the problem and see if you got the same answer. So I'm going to do a few different strategies for solving this problem. I'm going to do the standard algorithm and I'm going to do an estimation strategy, and I'm going to do what would you call this if you're thinking it, the area model. I'm going to do the area model. Okay, so go ahead now and look at the problem. It is 68 times 4. It is backwards on my side of the camera, so I hope it's not backwards for you guys, but it is 68 times 4. So if you've gotten this written down and you were able to solve this on your own, which I have faith that all of you are able to do, you can go ahead and pause the video and then go ahead and get started. Now that you have unpaused the video, I'm going to go ahead and solve the problem with you. So bear with me as I try to figure out the best strategy to hold this whiteboard up. So we've got 68 times 4. I think the first strategy I'm going to do is the area model. So I'm going to draw my box, and then I'm going to draw a vertical line and I don't really need to draw a horizontal line because it's a single or a 2-digit by a single digit. So I've got my 2 boxes, and I'm going to do 60 plus 8 and then 4 on this side. So right now I've broken it up into place values. So I've got my 60, so my 10s, and then my 8s and my 1s times 4. All right. Next, I'm going to do 60 times 4. Some of you, if you've worked with me, you know that I like to just pretend like the zero's not there because that's easier for me to multiply. So I do 4 times 6, which 4 plus 4 is 8, times 2 is, nope, that's not going to be right. See, guys, math is working out. So you got to work out the problem. Do 6 times 4. So I got 6 plus 6 is 12, and 6 plus 6, 12, add them together, and we get 24. So I can write 24 in for 6 times 4, but then I can't forget about that 0 because this is in the tens place. So I'm going to add that 0 back in, and now I have 60 times 4 is 240. So there we go, that's half of it. Now 8 times 4, 8 times 4. If you don't know that off the top of your head, totally okay. 8 times 2 is 16. Times 2 is going to be 32. So 8 times 4 is 32. Now, I want you to think about this. Now that I've drawn my area model, and I've got my 4 times 60 and my 4 times 8, we're supposed to do what with these? Are we going to add them together? Are we going to multiply them again? Are we going to subtract them from each other? Are we going to somehow divide them? What are we going to do? So I'll give you a second to think. I wish I could tell you to shout it out so that I could hear you, but it's totally okay. I know that you are all saying, I can feel through my teacher powers that you are all saying we're going to add 240 plus 320. 0 plus 2 is 2. 4 plus 3 is 7, and then 2 plus 0 is 2. So 68 times 4 is 272. Miss Hewitt's handwriting is, like you know, atrocious. So let me rewrite that. 272. Now, like I said, that was with the, I've got it right here. That was with the standard algorithm. Or I'm sorry, that was with the area model. So now I will do the standard algorithm. I'm going to just erase some of my work down here, but keep this part up. so that way you guys can see. So, my problem is 68 times 4. So 68 times 4. Now remember, when we work with the standard algorithm, we go from, we multiply the ones and by the ones and then the ones by the tens digit first. So 8 times 4, we already know, is 32. So I'm going to write down 2. And then I'm going to carry my 3. So I've written down my 3 on top of my 6. And then 4 times 6, we already know. Or 4 times 60. Did you see how I made that mistake? Super easy to make. I said at first I said it was the 6. But it's not 6. It's actually in the tens place. So it's a 60. Not a 6, but a 60. 4 times 60 is 240. We already know that because we did the work up here. 240. And then I'm going to add that 3. Now, something that could be super easy to make a mistake is by adding the 3 to the hundreds instead of to the tens. But think about it. We added the 3 in the tens place. We didn't add it in the hundreds place. We added it in the tens place. So we're going to add 3 to the 40, or 30 to the 40. We get 272. So there we go. Look at that. Before I said I was going to do an estimation strategy, but I think that because we broke it down with the area model, like, it's basically the same thing. But you know what? I take that back now that I've said it out loud. I'm going to do it anyways. So let's round 68. Let's think about, is that closer to 70 or 60? 70. So 70 times 4. 4 times 0 is 0. I hope you knew that. 4 times 0, any number times 0 is goose egg. So 4 times 0 is 0. And then 4 times 7 is... waiting for your answer. Just kidding. I know you're in a video. You can't tell me. 4 times 7 is 30... 28. 28, guys. Sorry, it's an early morning for Miss Hewitt. 28. So 280. So that's our estimation strategy. Are we close? I would say we're pretty close. We're just off by 8. So we are good. So I'm glad that you have joined me today for this fun math talk. And tune in for more videos like this if this is something you are interested in. All right, guys. Have a great day.